Good afternoon. Am I audible?
Good afternoon, sir. Yes, sir.
Okay. नमस्ते। देखते हैं आज हाँ परसों जाएंगे सुबह। आज कौन पूजा होगा? आज कलश स्थापन है। मुहल्ला का दिन ही होता है। काल हो गया था मुहल्ला हम लोग का। काल हो गया था 6 तारीख मुहल्ला था। ठीक। Slide is visible. Slide.
Yes, sir.
Okay. So last time started the switched networks. We have seen this when you want to communicate data from local area to remote place, then it can communication can take place through a network of intermediating or network through a network. There can be several networks, and the network will have several intermediate nodes, switching nodes. Those nodes will provide the switching facility. Those nodes are not concerned with the content of the data. Their purpose is to provide the switching facility. And also we have seen some of the nodes are connected to the stations, and some of the stations only their purpose is to communicate data through switchings, right? And some nodes, those who are connected to the stations, they can deliver data to the stations or they can accept data from the stations. So these things are there. And in this context, we have seen there are 3 types of switch networks are there. One of them is circuit switch networks, another is packet switch networks, and third one is message switch networks. In circuit switch networks, we have seen these. I will discuss in detail today. Here, there will be a dedicated path is there between 2 stations in circuit switch networks, and it is used in telephone network, public telephone network, circuit switch networks, or PBX, some exchange, or some exchange. In all exchanges, circuit switch networks are there, particularly for voice communications. Right. So, of course, data can also be transmitted over these telephonic lines. That we have seen it. Second type of switching is there. One is circuit switch network. And there is, I told you last times, that is packet switch network. Packet switch networks. In that case, it provides more efficient. I mean, it is more efficient than the circuit switching for huge data traffic, or for vast data traffic, you can say, right? That times you see in this case in packet switching, data are communicated in the form of packets, the small blocks. Data are transmitted in the form of small blocks. Those are called packets, and each packet contains the user data plus some content information for proper functioning of the network. So that is the packet switch network. Again, packet switch networks, we have seen it. There are two types are there. One is datagram approach, datagram packet switch network, datagrams. Another is the virtual circuit approach. Virtual circuit approach. Virtual circuit packet switch networks. In this case, we'll see it. We'll see in details. The datagram approach. Packets are treated independently, right? But in this case, I mean, they can travel to the destination through any path available, right? But in case of virtual circuit approach, first first logical connection is established, just like circuit switch network, very similar to circuit switch network. A logical connection is established between the two stations. Next, data are transferred. So each approach, there is some advantage and disadvantages are there. That would be those are most important. Depending upon their characteristics, they can be applicable to different cases. And depending on application, they can be applied. The different approaches can be used. So that is packet switch network, and third one is message switch networks that we have seen. I told you this is obsolete now, but still it is used in emailing. Message switch here, the whole message is here. Switches are there. The switch stores the whole message and then forwards it to the next switch. So in the these are the three switch networks. Not as far we'll focus. I told you we'll focus on these two networks. Those are widely used: circuit switch network and packet switch networks. In circuit switch networks, there are three phases are there. Three phases are there. One is circuit establishment. Circuit establishment. Second one is the data transfer. And third one is the circuit disconnect. So in this case, circuit switch networks, first a circuit is established between connection is established between the sending stations and the receiving stations, right? And these stations will be connected through several nodes. So in that case, you see, and also node to node can be different links. So depending upon the availability and cost, the node can select a particular link, and accordingly connection is established. I can say the last times what I have shown it. Let me just show you. It will be clear. It's not selecting. Okay, let me just wait. Okay, we have seen this last times. Okay, where it is? this one. Okay. So here you see how circuit, connection is established between the sending stations and the receiving station. Suppose A wants to send data to F, say station F or E, right? Then you see first a connection will be to be established between A and say E, right? Uh, and for these things you can see it here. A to 4 is already connected, so uh, A sends the request to the node 4 for a connections to station E. A sends the request to node 4 for a connections to station E. And you can see it here, A to 4 is a dedicated lines. So the part of the connections is a dedicated lines, there is no more line is here. So part of the connection is already established. Now the node 4 can select this line, the connections through 5 or through 7s. So depending upon this, the availability and the cost of the link, and this link can be FDM or TDM link. Multiple lines are there. So depending on the availability and cost, so A can select any of these two. So A selects say 5, 4, or to 5 to 6, right? Once this connection will be depending on the request, the connection will be established. So node 6 completes the connection, and after this one, say if node 4 selects this one, then this connection will be there. Connection will be established between 4 and 6, and 6 then node 6 completes the connection to E or F, right? And finally, a test is made to determine if the destination, say E, is busy or ready to accept the data, right? Accept this one. So in this phase, the connection will be in this way. Connection will be established. That is the first phase, circuit establishment. Right. Second phase is the data transfer. In the data transfer process, information now be transmitted from after this connection establishment connections, data will be transferred from A to the destination P or F, and this data can be analog or digitals, and it can be full duplex also. So that is the data transfer phase, second phase. And the third phase, circuit disconnect after some communications, after some period of data transfer, the connection can be terminated by any one of the two stations, either A or either E. So that is the circuit disconnect. So there are three phases of the circuit switch networks: circuit establishment, data transfer, and circuit disconnect. And you see this if you examine this circuit switching network, it is rather inefficient. Here that is inefficient in the sense that you see channel capacity is dedicated for the duration of the connections. Even if no data are being transferred, but still the connections will be reserved. This connection will be reserved. So for voice communications, this utilization may be a little bit high, though it is not 100%. But for if it is suppose if a computer is connected to a terminals, then you see capacity may be idles. If the connection is dedicated, then most of the time connection will be idles. So that is the drawback of the circuit switch networks, because of these dedicated connections. Anyway, this circuit switch concept, it is used in public telephone network. This is used in public telephone network. telephone network, right? Or also in PBX, this also used, and there are several terminology there when you use the public networks, subscribers. These things are there, subscribers, subscriber line, the link between subscriber and the network, subscriber line, it will be their exchange, in telephone network exchange are there, the switching centers in the network, that is the switching centers in the network exchange. And there will be trunks, branches between the exchanges, the trunks, trunk lines, trunks. So these are the some terminology are used in public telephone networks. Anyway, so let us focus on the concept of this, further details of the how a connection is established, more details through switches. Circuit switch. Switch also can be space division switch or can be time division switch. We'll see one by one. Circuit switching concept. Let us consider a particular circuit switching node. Right. A node circuit switching node consisting of main three elements. You see nodes. You have seen the nodes are used to connect the stations. Also, nodes are connected to another node. Right. So let us consider a particular node that consists of a collection of stations, and these stations are attached to a central switching unit. And this switch establishes a dedicated path between any two stations or any two devices. That two devices, devices those want to communicate. So let us consider one node network, elements of such one node network. Let's see what are the elements of switching node. So one element is the control unit. Control unit. Next, there will be interfacing. Several stations will be interconnected. This is digital switch. We'll see in details of this switch. Let us first see the concept, and this network interface, and these are connected to different stations, input-output lines. This is the network interface. interface, and you see how path is established. Among the stations. Here the full duplex lines. Lines attached to attached devices. Attached devices. So you see there are different, basically three elements are there. One is digital switch. This is digital switch. This function of this to provide a transparent signal path. It provides transparent signal path between any pair of any pair of attached devices. Now the question is why it is called transparent. That is because there is a direct connections between them. The path is transparent because there is a direct connections between them. Right. That's why it is called transparent. And network interface elements. You see, network interface. This one. This represents the function is to connect the digital devices. So data processing device, there can be different data processing devices, or sometimes and digital telephones to the network. Sometimes analog telephones also will be there. So analog telephones can be attached if the network interface contains the logic for converting to digital signals. So those are the functions of the network interface, right? And what is the function of this? The control element, control unit. The control unit, this one, it performs three functions. Three tasks are there. Three tasks. First, you see, it establishes the connections on demand. Establish connections as per requirement. Second, it must maintain the connections. Must maintain the connections because you see there can be time division principles will be there. So ongoing manipulations of the switching elements would be required. Right. So it must maintain the connections. And number three, it can be used for you see terminations. This continuity function, it can tear down the connections in response to the request from any one of the parties or for its own reasons. So termination of connections. So there are three functions are there for control unit, right? So the function is the function of digital switch. It provides a transparent signal path between any pair of the attached devices. Transparent in the sense because there is a direct connections between the devices. Control network interface. You see the function network interface. It may contain the software or hardware to connect the digital devices and the digital devices means data processing devices and digital telephones to the network. Also, analog telephone can also be connected to the network if the interface contains the logic for converting analog to digital signals. We have seen this how the PCM etc. The technique must be there, right? So that those are the functions of the network interface, and the control unit performs three functions: the connection establishment on demand, next maintaining the connections, and third one's the terminations in response to the request from one of the stations. Right. So these are the basic elements of a circuit switching node. And you see one thing I told you here, blocking, non-blocking, this term is used. The important characteristics of this circuit switching device is that you have to see whether it is blocking or non-blocking. Blocking or non-blocking. हाँ त्रिपाठी एक मिनट जस्ट मिनट हमें एक मिनट हेलो त्रिपाठी हाँ उसको लैंग्वेज लैंग्वेज थोड़ा चेंज करना पड़ेगा मतलब समझ रहे हो उससे ओनली एक मिनट को हम इसको थोड़ा एक मिनट इसको थोड़ा ये करते हैं अरे इसको कहाँ चला गया एक मिनट Hello, Arjavardhan. Am I audible now? Hello.
Yes, sir, you are audible.
Okay. Okay. Some confusion was there regarding your which questions. That's why I was discussing. Anyway, let me see what we are discussing. Okay. Okay. So we have seen this that three the elements of the circuit switching node. One is control unit. Its functions to three functions are there for control unit. A digital switch. The function is to establish the signal path, and network interface. It consists of hardware and software to connect the digital devices. Right, analog or digital telephones both can be connected with this network interface elements. Right here, the one thing you have to take care of this thing whether circuit switching circuit switching device whether it is blocking or non-blocking. Now, what is the meaning of blocking? Blocking means earlier I told you the network is unable to connect two stations. Here it indicates unable to connect. All the lines are busy. Connect all the paths, all the possible paths are in use. So unable to connect the two stations. And non-blocking means here you see all stations can be connected and all possible connections requests all possible connections will be considered. It can be granted as long as the called party is free. Of course, the called parties should be free. So non-blocking case, it permits or grants all connections, all possible connections, all possible connection request, possible connection. We'll see the examples that will be more clear. All possible connection requests. Right. And of course, here you have to see the. I told you that during establishment, you see the test is made whether the called party is free, is busy or free to accept data. So you see, in case of voice, now you see, suppose a party circuit switch network is here, then it can be used for voice and also for data, or can be both. So for voice, generally blocking is acceptable, but for data entry, this non-block for data entry, you see, non-blocking will be required. Non-blockings. That is the important things, because that times it's a computer is some comparison on say data entry is a computer is connected to the terminals. At times you see most of the there is since there is a dedicated lines, so it should be non-blockings because that times it can be connected for hours at a times, right? Voice communications for voice you see voice applications blocking is available in the sense because one or other party is almost or every times is speaking, so that times it is acceptable. Blocking is acceptable for voice, but for data communications non-blocking is required. So it will be more clear. This blocking, non-blocking concept will be more clear if you see the different switches in details. So one switch, let us see, that is space division switchings. Space division switchings. Initially, it was developed for analog environment. Now it can be used in digital also, digital case also. So you see in space division switching, the concept is their signal paths are physically separate from one another. I mean, it is separate in space, divided in space. So each connection in this case for space division switching, each connection requires the establishment of physical path through the switch, and that is dedicated to the transfer of signals between the endpoints. So that is the concept. And here, you see, here switches will be involved. The switches can be here metallic cross points. Can be switches can be metallic cross points, or the just like AND OR gates, can be logic gates, or can be semiconductor gate. In this case, right? So what I'm saying, space division switching, here you see the switch is one here where the signal paths are physically separate. Here signal paths physically separate, divided in space, physically separate from one another, and each connection requires physical path through the switch, which is dedicated solely to the transfer of signals between the endpoints, right? And it consists of these metallic cross points or semiconductor gates. Let us take examples, which is called crossbar matrix with input-output full duplex lines. Crossbar matrix, showing, say, this one's. Say there are 10 inputs, 10 outputs. Let's consider. That means 10 stations will be there. Each station, for each station, there will be one input, one output. Each station will have one input, one output. So say these are the, say, input. And the output. So they are the output. Input, output. They are the cross points. तो बात में क्लास ले रहा है, क्या सिर्फ साइन करना है? हाँ सर, क्या साइन करना है? समान वाला तबीयत खराब है। तबीयत खराब है, गला वाला बढ़ अभी ठीक है, अभी ठंडा लग रहा है इसलिए। क्या है ऐसे देख रहे हैं, वो तो लग रहा है, वो ठंडा लग रहा है, इसी चल रहा है ना, तो इसी में थोड़ा इसे भी अभी मौसम खराब है ना, लेकिन इसी में जरा वो लोग अभी गर्मी लगता है, अरे तो गला बढ़ गया था, अभी तो देखो अभी तो बात ठीक कर रहा है। दवाई अदरक का जो है ना सर, दवाई लिए सब ठीक हो गया अभी। नहीं सर, इसे थोड़ा दवा भी नहीं लेना है। वो सब जो कॉमन दवा है वही सब यहाँ पर काम करना जी। हमका डेट हो गया 7 ठीक है वो हम ही लोग का था बायोमेट्रिक टिकटिंग का अच्छा एक्सेप्ट ठीक ठीक so let's see here the cross points here the cross points and you see that these are all the cross points. The crossbar matrix, it is called crossbar matrix. Crossbar matrix. Each station is attached to this matrix through one input lines and one output lines. And there will be control unit for enabling the gate or enabling or disabling the gate. So one control unit will be there, like these things. This is these ones. Switch these ones. So there will be control unit. It can be connected to the stations. So interconnection is possible between any two lines. You see, between any two lines, this is input and output. For a particular input to a particular output is possible by enabling a particular cross point. So if you consider 10 inputs and 10 outputs, because one station will have one input, one output. So for you see, in this case, there will be for 10 stations, there will be 100 cross points will be there. 10 square, 100 cross points will be there. And so this is, you see, because of these things, the cross points requirement is quite large in this case. That is the drawback of this switch, of this particular configurations. So you can list the limitations of this crossbar matrix. Number one, you see the cross points increase with the square of the attestations. Say cross point is a function of the square of the square of the stations. Right. So if you want to add more stations, the number of cross points will increase. You see, tremendously. Right. That is one. So more cross points and more costly affair will be there. This is one limitations. Second one is if one cross point is lost, then the connection between any two devices will be affected. So there will be it will prevent the connections between. So loss of cross point. A loss of cross point will affect the connections between the two devices. This is the second limitations. Third limitation is, you see, these cross points are inefficiently utilized. Inefficiently utilized. Why it is so? Because you see, even all the attached devices are active. All the attached devices are active, but all the cross points will not be engaged. Only a small fraction of cross points will be engaged. So that is these are the three limitations of the crossbar matrix. So these these limitations can be overcome, of course, for multi-stage switch. We'll see next times. These cross points can be overcome with multi-stage switch. But number of cross points will be drastically reduced. That's for 10 inputs and 10 outputs. Instead of if you consider the three-stage switch, first stage, second stage, third stage, three-stage switch, then instead of 100, next time we'll see it, it can be reduced to less than 50, maybe around 48 cross points will be required for multi-stage switch. But here some problem will be there. It may be blocking, but here crossbar matrix it is non-blocking. Here all the you see paths are available in this case. It is crossbar matrix is non-blocking. Path is always available to connect an input to a output. You see, because of this matrix, a particular input can be connected to a particular output. But in multi-stage switch, even you will see it, even the lines are free, it is not busy, still you will not be able to connect that particular input line to a particular output lines. So blocking problem will be there in this case in multi-stage switch. But here it is non-blocking. Okay, today this much. Next time we'll see it. If you have any questions, anybody you can ask. Mr. Vardhan, any questions?
No, sir.
No, sir.
Okay. Anybody else? Any questions? Circuit switch networks. Circuit switch network. One more is configuration. There is multi-stage networks. Next, we'll see the time division switchings. By using interchanging the time slots, also we can switch. The switching facility can be obtained by interchanging the time slots. That will see it. Time slot interchange is here. Here it is physically connections physically separate, but that times by exploiting the time slots we can have the switching facility. Anyway, next time we'll see it. Next time most probably after the setup. But you see next week also maybe I'll be, but I'll just if I am not able to take the class in a particular day, then I'll give the message to WhatsApp. So then I'll give the message to you also.
Yes, sir.
Yes.
Tomorrow quiz is there at 1 to 1:30. Okay, 1 to 1:30.
Yes,
that
sir.
is
Yes, sir.
okay. Okay.
So till where we'll get the portion?
Till this portion, till this portions, this circuit switch networks, till the portions. Basic here, basic concepts will be there. It will be not details. No further details. Just basic concepts. Just basic concepts, right? Different switches and basic concept of circuit switching. We're not going to details of it. Okay.
Yes, sir.
Any other queries? Any other queries regarding quizzes? Yes. Any other?
No, sir.
Okay then. Okay then. Next class we'll see it.